Hi, welcome back. Today I'm going to be looking at a slightly different way of mounting a DRO reed head to the cross slide on one of these lathes. Because people say it, I'll just get this out of the way now. I do know that there are draw wire encoders available out there. The main drawback with those is one, they cost about the same amount as the entire DRO kit that I bought, and two, the resolution isn't so good. So that's the reason why I'm not going to get one of those. I deliberately bought this low profile scale, hope that it would make fitting to the cross slide a little bit easier. Now I had thought that I might be able to lose it in this gap back here where the lead screw is, but that would necessitate either moving the splashback back or cutting a slot for the scale to run in. I've seen them mounted on this side because it's clear of these adjusting screws, but unfortunately it's not clear of the chuck. I reckon I'd have this destroyed in a matter of seconds if I mounted it on the front there. Mounting it on the back, like I say, these are in the way, so you've either got to mount it horizontally. I think Blondie Hacks did a similar thing with her magnetic scale, which is an option, which I'm going to use as a backup option. Other people have seen mount it further out, like this. Problem with any mounting in this side is that it interferes with the tailstock. The tailstock comes all the way up to the saddle. On many occasions I've needed that all the travel of the quill, well, and some, especially if you've got a centre in here. So I really don't want to sacrifice that travel. So the solution that I'm going to try, at least, based on a conversation I had with Neil from Nell's Mechanical Man Cave some time ago, is to mount the scale perpendicular to the cross slide and then use a cable pull system and a spring to move the reed head. Obviously there's going to be some play in that system which you wouldn't necessarily get with a rigidly mounted system, but I want to see how well it works. I like the idea. It keeps everything nice and compact, doesn't get in the way of any existing parts of the lathe, and if it's no good I can always come back and mount it like everyone else does. So this is the setup I've devised. Here's the scale and the reed head. I've decided to support the reed head with a guide bar with bushings. So I've got an old rod with bushings out of a printer, which was perfect for the job. The cable to the cross slide will come over this pulley and around this one and attach to the reed head here, and then there'll be another piece of cable that attaches to this spring here, goes around this pulley, and then again onto the reed head. So I'll preload the spring so that it's always pulling even when it's right up this end. There's a few parts to make. There's pulleys, pins. I've obviously done those already and expertly managed to not film any of that. And then we've got 3 blocks to make and a back plate. So this is the shaft with bushings. These are going to fit into this guide block. Right, so start off by finding the top of the material. We'll call that 0. X0. So I've got enough blocks sticking out so I can just machine all the way around, create the part, and I'll just have to flip it over and skim it to length. Because I need a low profile head to clear the bar, these cheese head screws are the best I've got. So they'll have to do. If this all works, there'll be some Loctite action, but for the moment we'll just go with nipping them up. So this larger block, the closest bit of material I've got is this 25mm square bar. This is 25 by 20, so I'm just going to have to skim a bit off. The slot I'll do with a slit saw, and then it's just drilling a couple of holes. Look at that finish. That was supposed to be 60mm long, and on my skim cut, just to clean it up, I've ended up at 59.99. Look at that. Couldn't have done that if I tried. Now to take 5mm off the height, so we've got a 20 by 25 block. I'd call that 20mm. So I've expertly managed to cut that slot on the wrong side, so I'm going to recut that. I won't bore you with filming that again. So I've assembled the blocks on, they're all screwed in from behind, and the wheels are on. Used E-clips to retain those on the pins that I made. So two that way, and then I've got this one that way, which has got a pin pressed through there, which is press outable should I need to move it. Just packed it with a washer to try and get the slot there to line up with that slot there roughly, so when the cable comes around the corner it's a nice smooth run. So now I need to make the little pegs that go in here to hold the cable. So I found a couple of bits of bar. This one's already got a cross hole in it. This one's got a flat, which should make it relatively easy to punch a hole through. The wire will go nicely through that hole. I'm going to put a M3 grub in the end to hold the cable, both of these, and then reduce the section and thread that to go into the reed head. Okay, so that's the two cable thingies fitted, and I've run a piece of cable round here and to the spring. I've also made just a bolt with a hole through to hold onto the cable at the spring end. This corrugated cable conduit is going to have to be managed because if it snags on here it's going to cause a problem, but as long as it's out the way, that's working quite nicely. The next step really is to mount this on the lathe. This contraption here that I'm using to lift this This end of the lathe is a motorcycle lift. This one's rated for 150 kilos, so whilst it won't lift the heavy end of the lathe, it's quite happy doing this, and it makes a job like this a lot easier. There's a bar across the bottom there which I've slotted in, and it stops the scissor collapsing if the hydraulic pressure was lost, for instance. So the idea is this will mount something like that, so the wire from here can go over the top, down the side of the lead screw here, and then into this nut block somewhere. So that's a good position there to fit, but unfortunately there's no room to fit the chip guard, which I obviously thought lots about until now. So what I'm going to do is I'm going to drop it down so that that screw hole is on this lower part of the saddle, and then I'm going to use that hole and another one here to secure it. Bad news is there's way too much backlash. You can see it flexing, and you can see it relaxing and tensioning up as I go backwards and forwards. The spring isn't strong enough to keep it taut, so I need something a lot more flexible. So I'm going to try out this Kevlar, Kevlar thread. That's a lot more flexible, so hopefully that should be able to be kept taut. So it's working somewhat better with the Kevlar, but we're not quite there yet. So if I zero the X, I've zeroed this dial indicator, and I'm going to move it 1 millimeter on the dial indicator, and that's giving us nearly 2 millimeters, which is nearly correct. It should be 2 millimeters. So if I go backwards 1 millimeter on the dial indicator, we're only at 0.7, so there's a hell of a lot of backlash there. Now if I wiggle the cable, it sort of makes its way back towards 0, but doesn't really get there. So it doesn't work, which is not unexpected, but disappointing, because I was hoping that this would be a nice, neat alternative solution to the various other mounting options, none of which are optimal. One bit that could be improved, where this pulley is positioned isn't quite right. This would need to be higher up, so that the pull to the block, the nut block in the cross slide, is a straight line. Currently it's the hypotenuse of a triangle, and as the cross slide moves towards it, the angle of that hypotenuse changes, so you're basically getting a cosine error as you move the handle, which changes through the travel, so it's not just a constant that you can calibrate out. That said, that's kind of academic, because the slop and stiction in the system is too much to cope with, really. It's not repeatable enough. My only thought would be to run another piece of wire, so get rid of the spring, so have a pulley at the front, so that you've got one piece of string that comes around the front and comes around and does the same work as the spring was doing, but you've effectively got a pulley and a push at the same time. As long as those bits of string, whatever they're made of, were suitably taut and were not going to stretch, then that might work well enough to deal with some of the issues, but I can't really see a good place to put a pulley up front here without machining bits out, which I don't really want to do. So was it a waste of time? Well, no, because this was an idea from Neil. As I said at the beginning, Neil's had a lot of very unconventional but really good ideas on his channel, and this was one we discussed when we met up, and been wanting to try it out ever since, and I have now. Lots of machining practice doing it, so that's always worth something, but unfortunately this one's going to have to be written off as a not quite good enough. So I'm going to try and work out how best to fit that, and obviously do the other readouts, so that will be another video. I hope you enjoyed that. Thank you for watching.